Hi, good morning. Uh, this is OR, okay, Operation Research. And before the midterm, we discussed about how to model things into game, right? And then today we are going to discuss about how to compute the zero-sum game. Okay? And then, if possible, we can also continue with non-zero-sum game. If possible, we finish the game theory today. If not, next meeting. Okay, so the slide is in Lentera, so you can also follow on Lentera. Share my screen. There. So this is what you. Oh, this is your assignment, right? I did not check. Did you make it? Okay. 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 Oh, okay. So please make it. Okay. So I think you are here in the Lentera. You have. Oh yeah, you did not make it. Olivia make it, but Joy did not. Okay. Can you make it? Huh? So today we'll discuss about it. So this is finished, introduction to game theory and zero-sum game. So we try to finish these three today, if not maybe until next week. Huh? Then we discuss about queuing theory. Okay. So this is what we have. Oh, it's very long. So at this point, you're supposed to know how to create the payoff matrix for zero-sum game. Okay, so from your real-world application, you just create a zero-sum game payoff matrix, and then now we are dealing with how we will compute, okay, the zero-sum game. Okay, so in this course, you will learn about what is saddle point, okay, value of the game, and then how we will compute the solution for zero-sum game through domination or mixed strategy, and then we will use also linear programming. And at the end, in this course about zero-sum game, I will show you that about scaling property of the game. Yeah? Okay. In zero-sum game, I hope you still remember, we have two agents. Okay, I call these two agents Miss Row and Mr. Column. So if you don't like, you can change. Okay, the name. The payoff matrix is always for the Miss Row, always. Okay, that means if you want to see the Mr. Column payoff matrix, because this is zero-sum, that means you just take the negative. Yeah? So if Miss Row select A and Mr. Column select C, okay, the payoff for Miss Row is 4 and the Mr. Column is -4. Okay, I hope you still remember that. Okay, so the positive payoff indicates the payment for Miss Row, and negative payoff is just from payment from Miss Row to Mr. Column. Okay. Okay. So consider this game. 6, 5, 5, 4. So how Miss Row will select her strategy, and how Mr. Column will select his strategy. You remember that they are both rational. Okay, so they are both playing safe. So what do you think? If you are Miss Row, what you will do? Think about it. If you are Miss Row, what you will do? So say if you are Miss Row, if you select A, right, and then Mr. Column select C, you will get 6. Okay? But you don't know what Mr. Column will do, right? If Mr. Column select D, you will get 5. Okay? And if you select B as Miss Row, okay, and Mr. Column select C, you will get 5. But if Mr. Column select D, you will get 4. Of course, you want to maximize. Right? So what you will select? Oh, of course, in this case, you will select A, right? Okay. So what is the algorithm? Okay, so Miss Row. So Miss Row will find the minimum in each row. Okay. Why? Because that is the worst payoff for each choice, right? And then Miss Row will find the maximum among the minima. Okay, so remember the payoff represent the gain. Okay, so G, J, K, J is the row, K is the column. Okay, so first you do a minimum and then you get the arc max. So, okay, so basically Miss Row, Miss Row will do a maximum gain. Yeah, so that's the strategy. So in this case, the minimum is A is 5, okay, and then from B the minimum is 4, okay, and then you get the maximum between 5 and 4, right? So between 5 and 4, the maximum is 5. So in this case, Miss Row will select strategy A, okay, so that she will never receive payoff smaller than 5, right? So at least she will receive 5 if she did A. Oh, how about column? Yeah, Mr. Column will find the other way around, right? So is for Mr. Column, this is a cost, not gain, correct? Okay, so this one is negative. So in that case, we'll do minimax. Okay, so exactly the same. So Mr. Column will find the maximum for each column because that is the worst possible payoff, right? And then we'll find the minimum among the maximum. Yeah? So minimax the cost. Okay, so let's take the example. So now Mr. Column, what Mr. Column will do? For each column, get the maximum, 6 and 5, right? And then among these two, get the minimum, which is 5. Oh, so Mr. Column will select strategy D, right? In this case, because he will be guaranteed never receive loss greater than 5. Yeah? Remember, this is cost, yeah? For Mr. Column, this is negative. So, the worst case, okay, is 5. Okay. This means 6 means cost is 6, negative 6, so this is worse than 5. Okay, is it clear or not, Livy?
Yes, it's clear.
Clear, yeah? So, this is the nice thing about this game. Yeah? When the larger row minima is equal to the smaller column maxima, this game is called to have a saddle point. So not always have, okay? Not all game have saddle point, but when the maximin equal to minimax, we say that this game have a saddle point. So that saddle point is the equilibrium. You already learned the difference equation. You already learned about equilibrium and stability. So this is exactly the same. This is also equilibrium, okay, in game theory. Okay. So the saddle point is the game solution equilibrium. So when a game has a saddle point, then that saddle point is also called the value of the game. Okay? If the player play rationally, okay, you can expect that they will select that strategy. Okay? Unless your opponent play poorly, not rational, okay, then on average, you cannot win more than the value of the game. So the value of the game is important because in this case, you talking about fair game. Yeah, if the game value is 0. And if the game value is positive, you will say, oh, Miss Row is always winning. Yeah? If the value is negative, you know that Mr. Column is always winning. Okay? That's the meaning of game value. Okay. In our example, you see Miss Row will select strategy A, right? And then Mr. Column will select strategy D in this case. So this 5 is the game value, okay? And this intersection of the two strategy, okay, this cell is the equilibrium. Is it or not? So the equilibrium, because this is discrete, right? So the equilibrium is in the cell, yeah? AD. Yeah? Strategy AD intersect at P of 5, that is the equilibrium. Is this clear, the equilibrium in this game? Okay. Okay, so I just summarized the steps to find the saddle point. Okay. So first you examine the game matrix, okay, from the point of view of row, and then from the point of view of column, okay, your opponent. Okay. And then list the minimum of each row and mark that as asterisk, okay, with the greatest of these. And then for list the maximum for each column, and then again you mark asterisk for the list of these, okay. And if the two mark intersect in one cell and has the same value, that is the requirement, okay, then the game has saddle point, okay. Then you say, okay, this is the prediction that the player should use these strategies, the two of them, if they are rational. And then if the saddle point exists, that is the value of the game. Clear? This is just the summary. Okay, practice. What is the value of the game? Is there any saddle point or not? So for the row, you get the minimum. For the column, you get the maximum. The minimum is 2 and minus 5. So then the maximum is 2. The maximum for this is 4 and 2. The minimum is 2. Oh, it's exactly the same. Right? So, okay. Just look at the table. You already, using your mind, you can already decide without even doing anything. Yeah? Very simple. Okay. So you get exactly 2. So in this case, maximin equal to minimax. The value of the game is 2. Right? Clear or not clear? Super clear. Okay, good. How about you, Livy? Is it okay?
Yeah, it's okay.
Clear, yeah?
Yes.
You can do it, right?
Yeah.
It's very clear. Okay. So this is the result. Okay, can you find this the saddle point of this game?
So,
So
seven,
minimum is -7 and -5.
minus
So
minus 5, minus 10, and minus 4.
maximum is 1 and 10. The minimum is 1. Oops.
1 and 10.
Oops.
Hmm.
What is oops? The minimax is not the same as maximax, isn't it?
Yeah, it's different.
It's different. So we don't have saddle point. Okay? So the value of the game we don't at this point. Okay? Because they are not the same, you don't have saddle point. Okay? Oh, this game does not have simple saddle point. Okay? Later we will know. I will show you how you calculate the saddle point of this game. Okay? So, but at this point, this is called simple saddle point. No. Okay? There's no saddle point. Okay. But you still want to know the solution, right? Because, okay, I know this situation and then I can create the payoff matrix, okay? And then after that, you want to get the solution so that you can predict, right? What is the opponent will do, and then what is the the result of this game, then you can predict, right? Okay, so one way to find the solution of the game is through domination. Okay, so what is domination strategy? Okay. A dominant strategy is a strategy that gives you a higher payoff than all of your other strategy, regardless what your opponent does. Okay? So if one strategy is superior to another for all cells in row or in column, then that superior strategy is called dominant. Not always exists, okay? But if you can find it, then you can remove the dominated strategy. Okay? So how do you know dominant? If you are in row, you maximize the value, right? So larger row value, that is dominant. If you are in column, you minimize the value. So smaller column value is dominant. Okay? If domination exists, okay, then the game matrix is reduced to show only dominant rows and columns. So this is a technique to reduce big game matrix into smaller. Okay, example. In this example, you look at the row. Okay, 4, 2, 3, minus 5. So if we look at the row, 4 is larger than 3, correct? 2 is larger than minus 5. So this row B is dominated, you know? Row A is dominant, right? So in that case, row B I can delete. Why should I care about row B? I don't need to care about it, right? Because this is clearly this is not dominant strategy. Okay, remember for all cells, okay, for all columns, okay, row A is larger than row B. In that case, yes, row A is dominant. Clear? Superior.
Mm.
Okay, let's take another example. How about D now? Okay, 4 and 2 compare, right? For B, you compare the column, right? So 4 you compare with 2, 3 you compare with minus 5. Which one is bigger? Oh, A, column, you get the smaller value, right? 4 and 2, smaller D is smaller than 4, yeah? 2 is smaller than 4, minus 5 is smaller than 3. That means column D is dominant. Yeah? Column C is not useful. So in that case, you just delete column C. Is that okay? So,
Delete column C.
yeah, so you will have like this. Right? Column C is deleted. Easy or not? Then now you see uh, dominated by row, dominated by column. Now we use both. Okay, we use both. So say the same name matrix here, either one. Okay, say I start with row. Okay, I know that strategy A is dominant over B. So I remove B, okay, delete it. And then now in here, between 4 and 2, hey, this is column. I need to get the minimum. So 2 is smaller than 4. Then, oh, I get only one cell. That means I get the saddle point. Easy. Okay, so this is a technique, okay, through domination. So you can also use this, okay, instead of getting the maximum, minimum, okay, you can also use another way with this through domination. Clear or not? Okay, this is the real world event, okay, during World War II, okay. This is in the West Papua. No, East Papua. Okay, West Papua is Indonesian part, so the East Papua now become Papua New Guinea. Okay, so in South Pacific in 1943, General Imamura has been ordered to transport Japanese troops across the Bismarck Sea. That one that you can check there. Okay, so they want to put the troop across the Bismarck Sea to New Guinea, and then General Kinney from US want to bomb that troop transport. So Imamura must choose two routes, okay, shorter in the north or longer in the south. And General Kinney must also decide where to send the plane. Remember this plane at that time, yeah? So there is no satellite. Okay, so they need to really decide at the correct place, otherwise will not win. Okay, so they need to send this plane to look for the Japanese. Okay, so if Kinney send his plane to the wrong route, he can recall them, but the number of days of bombing is reduced. Okay, and this is the payoff matrix of that. If you look at this payoff matrix, it's actually positive and negative. Positive and negative is zero sum. Okay, so the first is for Kenny. The second number here is for Imamura. Okay, because this is zero sum, so you can start to use domination. Okay, so first you check for, okay, let's check for Kinney. Okay, 2, 1, 2, 3. Oh, for Kinney there is no domination. Okay, why? Because 2 is larger than 1, yes, but 2 is less than 3. So it's no domination. Okay, in that case, let's go to Imamura. Okay. So Imamura have north is weakly dominated the south. Okay, so if you look at this, 2, 2, okay, and then 3 and 1. Well, this is not actually larger, but this is equal, right? 3 is larger than 1. So in that case, remember in column you want to get the minimum. So meaning north is actually dominant over the south, right? For Imamura. Okay? So when we said weakly mean there is an equal, yeah? Not just larger than or smaller than, but there is also equal sign. Okay? So that's why we said weakly. And the north is weakly dominate the south, so we can delete. Delete the south column. Once you delete the south column, of course, now you can see for Kini, 2 and 1, right? So this is row. Row is maximized. Okay. So north should be the dominant. Okay. So the result is north, right? That is the equilibrium, and that is really what happened during World War. Okay. So okay, so practice. Wow. You remember mouse and cat game last time in the previous slide, right?
Oh yeah.
Do you still remember? So the mouse and cat will either move 3 steps. Okay? If the mouse still alive, okay, the mouse will be rescued. So, and this is the payoff matrix of the mouse and cat games. Okay. Now, in this case, can you find dominant row and dominant column so that you can reduce? Okay. So 4 rows. Uh, hmm? Yeah, you can if you want you can use your annotation here. Okay, just delete the you just make an annotation here. Which one you should delete? Which row and which column? Yes, because compared to yeah. Okay. Leafy, can you do the yeah, you do the row and leave it to the column, can you? For the row you get the maximum, for the column you get the minimum.
Okay.
Okay.
So I do the column.
Yeah,
Right.
please do the column, yeah. You get the minimum is dominant. Okay. For joy,
What?
the one with your star is dominant. Okay. So, Livy, which one is dominant in column? The less.
The dominant. It's
The one that always
is
minimum compared to the others.
but we look the one or
Every two.
for the
Look every two. Okay. So here 0 and 0, 0 and 1, 0 and 1. This is the same, right? This is also this column 1 is always less except this one. So this is not dominant, right? And then you
Oh,
compare. Okay. So compare these two, for example, 1 and 3. Okay. 1 and 3 is 0, 0 is equal. 0 and 1, this is dominant, right? 1 is dominant. This is dominant again. This is equal. This is dominant. Okay, but this is not. So this is not dominant. So now you look for a column that always dominant. That means always less than the others.
Always less than the others. So it should be this one.
So what you will do is you can do it first and in the row. Okay, if you get difficulty, you can get first in the row, and then from that dominant only, because all the others are removed already, from that dominant only, then you can get the minimum. Say, in this case, Joy already get the dominant, which is 4 and 5, right? So in that case, you only consider this matrix.
Oh, okay.
Okay. So clearly, column 2, 3, 4, 5, 6, 7 are all the same. Okay, they are not dominant. Okay.
So 1 and 8.
Okay, so 1 and 8. So let me get my mouse. Okay, so cut strategy 5 dominant to 1, 2, 3, 6, 7, and then 4 again dominant over 8 for the row, and then after that you can have this only 2, right? And you know that for the column, okay, the mouse strategy 1 dominate over 5, 8 dominate over 4, and then all the others are alike. So you can also put it together like this, okay? And eventually you will have this reduced matrix. Okay, so it's very simple. Is it clear or not? Okay, so from very big matrix, using domination, you can actually reduce the matrix. Yeah, so what is the solution in this case? What will be the solution? For row, you want to minimize, so 0, 0, and then, so you do not get 0. For is there any domination again here? No more, right? So we can also, because this is equal, so we can also reduce column 2, right? This is exactly the same, so we can reduce. And then from there, we can get the, we know that there is no saddle point. Yeah? From here, this is the last payoff matrix that we have. And there's no more domination, but actually much reduced compared to earlier, right? Okay, so, and you know also there is no saddle point. Okay, so, hey, come on. From earlier, we talked about game theory with saddle point, okay? And when we don't have saddle point, then suddenly we are stuck there. Oh, there is no solution because no saddle point. Okay, anyway, so this is actually happened in the history. When they start to learn about game theory, they know, oh, I can solve using saddle point. Okay, They were very happy. Oh, maximin equal to minimax. Wow, I get the subtle point. Okay, that was in 1947 or 1946. Okay, game theory was developed at that time, and they are stuck. Oh, after that, I don't know how to solve if I don't get subtle point. Okay, and then after several years, okay, and in our class it's just several minutes. Okay, okay. After several years, they found out how to solve that. Okay, so if the game has no subtle point, how to find the solution of the game, right? This question takes several years to answer in real life, okay, in the history, but in our class, only several minutes, okay? So, is there any idea? Is there any idea how to, to solve the game without subtle point? What do you think? Is there any idea on how to solve the game without subtle point? To clear up there. So the idea is to use probability. Okay. So the earlier game, so now to solve that, okay, we call that strategy of the game theory. They call it pure strategy. Okay. Why it is pure strategy? Because it's a strategy where you stick to play one game only, right? So if you play only one game, okay, that is called pure strategy. That means you are stuck there, you cannot solve it because there is no subtle point. Okay? The solution is called mixed strategy. What is mixed strategy? Okay, you have the same game, but you play many times. Okay? And in that case, sometimes you play this, sometimes you play that, right? Okay? And because you play so many times, okay, then there is a probability that you play this strategy, you play that strategy. Now you find the probability, okay? Imagine that you play so many times so that you can play, so that you can get the probability, okay? And now when you find the probability, you will get the solution. Do you get the idea or not? Okay. Pure strategy means you play only one time. Mixed strategy means you play many times in order to get the probability. Okay. Of course, in practice, you don't do many times of the game. Okay? You just directly compute the probability. But the idea behind that probability means you play so many times. Is that okay? So the grand strategy governs your choice of pure strategy to play at one game. Okay, when you know the probability, of course, you know if I play that strategy, I have how many percent of winning. Okay, so what is mixed strategy again? It's a grand strategy which is to let the decision of each particular play is governed by a suitable chance device. So, okay, we have what is called probability. Sometimes use one pure strategy, sometimes use another pure strategy based on random probability distribution. Okay, so for each pure strategy, there is some art that you can play. Okay? Art is basically the same as probability, right? So let's find the art. Okay, the game with oil drilling a while ago. So this is how you will find the art. Say, let's say for drilling, I put X, right? And then for no oil, I put Y. Because this is probability, the sum probability is 1, right? So then this one is 1 minus X, and here is 1 minus Y. So I want to get the probability. So first I get the odd first, or the probability, okay? So what I will do, minus 7 times X plus 1 minus X times 1 must be equal to 10 times X minus 5 times 1 minus X. Okay? From here, if you do algebraically, you get X equal to 6 over 23. So you get the probability of drilling. Huh? The same thing with here. Okay? So minus 7, this is the payoff, right? Multiplied by Y plus 10 multiplied by 1 minus Y, okay, must be equal to, okay, this one, Y times 1 minus 5 times 1 minus Y. And then again, you just do algebra, then you get the Y. Okay? So, this is how you calculate the probability or the R. Clear or not clear? Okay. How about you, Lizzie? Clear or not? Can you
Yeah.
do it? Clear, yeah?
Clear.
Okay. Now, because you get the probability to get the odd, you just multiply by that denominator, right? Because this is earlier you see 6 over 23, 15 over 23, right? Then easy, yeah? You multiply by 23, you get the discrete value, right? So you get 6. Of course, the total is 23, so this must be 17, right? So the same thing here. This is 8, so this must be 15, okay? So this is the odd. So based on the odd, you know that you will, the strategy of the action must be selling. For the strategy for this one is no oil. Yeah, so you already know what will be the equilibrium value with this one. Okay. Okay, so if you want to compute the long-term expected value for each row and column, so okay, for drilling, you get 15 times minus 7, okay, and then plus 8 times 10, okay, 8 times 10, so drilling, right? And then for selling, you get 15 times 1, so again 15 times 1 is here, okay, and then 8 times minus 5, okay. So then again you get the value is, what is this? Negative 25 over 23, okay. And now if you check the value of have oil and no oil, the same thing, you put it inside, and amazingly, if your result is correct, okay, you will get exactly all the same with this negative 25 over 23. Yeah? So this is actually the game value. Okay, if your computation is correct, okay, you can check the value is all the same for all alternatives. Yeah? Oh, so you know you get the game value, okay, which is negative 25 over 23. So this is negative. What that means? This is unfair. Okay, 0 means fair, negative means unfair for the row. Okay, that means no matter what you choose, you are losing. Is it clear or not? So on average, that company cannot win in this game. If you play a long term, okay? you cannot win. Is this clear? So you know how to compute the probability, then you know how to interpret the value of the game. Yeah? Oh, okay. Practice. Can you do practice? I want you to create the payoff matrix, and then I want you to compute the equilibrium, the value of the game. Okay. Frank cannot remember if today is okay. Yeah, this old man loved his wife, so but he cannot remember, okay, that today is his wife's birthday or not. And he goes home late, so everything is closed except for the florist. Okay? If it is not her birthday and he bring no gift, it is okay. So payoff is +2. If it is not her birthday and he bring gift, she get confused but happy. So say you get +1, which is smaller, right? And then if it is her birthday and you bring no gift, she may get upset. So that -10, right? If it is her birthday and he bring only a flower, she may be happy. So 1.5. Okay. So you create a payoff matrix and start to compute. Okay. And what is the decision in this case? I don't know. If you get the value of the game saddle point, in that case you don't need to compute probability, right? But if you cannot find the saddle point, then you calculate the probability. Yeah, this is very easy. Okay. So yeah, this is dominant strategy. So actually, you don't need to calculate. Is that correct? 2, 1. Oh no, this is not dominant. 2 and 1 minus 10 and 1.5. This is row is no domination. How about column? 2 and minus 10, so this is dominant. Oh, this is no domination also. So there is no domination, right? How about if you calculate the maximum and minimax? So you get the minimum, which is -10, correct? And you get the minimum, which is 1. So maximum is 1. In here you get the maximum, so this is 2, this is 1.5. So minimum is 1.5. So there is no saddle point also. So in that case, you need to calculate probability. Huh? So yeah, this is the answer. So when you calculate the probability, you're supposed to get this value. Okay, try first so that you can have the experience to calculate. we are able to calculate the probability I don't know if my computation is correct or not. You need to check, okay? This is actually came against nature, but we can also put it into game matrix. Yeah? Just like decision theory, right? Oh, in our class, we will put the absent, Joy, or okay, please, please. And you get this value the same? No?
Mm,
Yeah, you can use algebra to solve this if you want. So probably that will take some time. You can also use Excel. Okay, later I will show you how to use Excel using Excel solver. Okay, okay. So look at the interpretation first. Eh? If you look at the probability or the art in here, the art in here, buying flower is 12, empty hand is 0.5. Clearly, buying flower is dominant strategy, right? Okay, the same thing with birthday or not birthday. The probability or the art is much larger here. So in that case, this cell will be the equilibrium. Okay, so if you are frank, you will buy flower regardless, right? Okay. So the average payoff is always the same when good mixture is found. Yeah, like a while ago. Yeah. So 1 minus 25 divided by 23 a while ago. So if the presumed good mixed strategy does not yield the same average payoff, okay, then the presumption is wrong and the mixture strategy is probably not the best. Okay, so this is another method. Okay, if you have only 2 by 2 like this, okay, you want to get the out for the columns. Okay, this is how you get it. Okay, again, this is based on rule of thumb. So, okay, if you want to do it by hand, okay, say you don't have computer at that time, you have a decision that you need to do it in the field, for example, yeah. So you are in the factory or in the company, you have only paper and pen, and then you want to do computation by hand. Okay? This is how you will do. Okay? This technique is only for 2 by 2. Okay? If your matrix is not 2 by 2, you cannot do. Okay? So the technique is simple. Look at this. First, you find the difference between rows. Okay, so in this example, -7, -1, okay, -10, -5, okay, and then you get the positive value. Okay, this is what 8 and 15, right? Okay, and then you reverse. Okay, the odd is 15 and 8, so you reverse. So no oil is 15, F oil is 8. Oh, easy. Okay. Okay. So this is just a trick, okay? Only for 2 by 2. The same thing for the row. Yeah. So again, you find the difference between column. Okay. So here, -7, -10. Okay, and then 1 minus -5, so 6, right? And then you get the positive value, which is 17 and 6, right? And then you reverse. Okay, so now you get 6 and 17. Easy or not? This is much easier, okay, than you compute algebraically. Oh, crazy. Okay, one by one. So this is a trick in computation if you have only paper and pen, okay, and only for 2 by 2. Okay, I hope this is useful. Oh, okay, practice. What you will do first, find if there are any minimax equal to maximin. Okay, if you cannot find, try to do domination. Okay, if you know you cannot do both technique, then you need to find the probability or the R, right? So then use that technique. So maximum for each row, 3 and 4. Minimum, 3. Right? Oh, no. Minimum. Minimum is 1 and 2. And then the maximum is 2. Maximum, 3 and 4. So there is no saddle point. Right? Domination. No. Column is not dominant. How about row? Row is not dominant also. So you cannot find domination, you cannot find saddle point. Then the only way is to do mixed strategy, right? Using probability. Oh, you get you minus, you take the absolute value and you reverse. Okay. So 3 minus 2, 1. 1 minus 4, 3. So you reverse. And so, can you get it or not? Yeah. So 1, 1. Okay. Okay, so in that case, game value is just, okay, 3 plus 2 divided by 2. So you get one of them. Okay, just one. So you get 2.5. Any strategy, any cell that you want, any column or any row that you want, you can get the same game value anyway. right? Is it clear or unclear? Can you calculate, Livy?
Wait, I'm a bit confused with the odds, like the A after the A and B, there's a column like 1, 1, right?
Yes. Remember, the technique is just minus,
Uh-huh.
take the absolute value, and then reverse.
Oh, okay.
Okay.
Absolute.
So
Mm,
3 minus 1, 2, right?
yeah.
And then 2 minus 4,
Oh.
2.
Huh?
Minus 2. But you take the absolute value, so 2. So 2 and 2, right? And then you reverse. So it's the same. It's 1, 1, right?
Yeah. Oh, okay.
Okay. Got that. Easy, right?
Yeah.
Okay. So, again, now I have a trick again. A lot of trick. This is only for 3 by 3. I don't know if you like it. If you don't like, we can just skip this. No problem. This is just rule of thumb, okay? You subtract each row from the preceding one, okay? And then delete the column that you want to find out, and then you do a cross product of the matrix, okay? AD minus BC. Okay. This is just to get the, only for 3 by 3. So here is example, right? So for each row, A and B minus, and then B and C you minus. Okay? After you get the minus, what you will do? You remove the this column D, subtract each column, and then delete the column that you want to find the R. Okay, so suppose you want to find the R of column D, right? That means you remove this one. Is it clear? Now you have only this one, right? Then remember this is A, B, C, D. What you will do? AD minus BC. Okay? So AD minus BC, you get 38. That means the out of D is 38. One by one, you do like that. Okay? Again, I don't know if this is, anyway, for 3 by 3, if you really need it, okay, then you use this trick. If not, maybe 2 by 2 is enough. Too much trick. Okay, the same thing, yeah, for the row. Okay, subtract the columns and then delete the row that you want, and then again you use the same thing. Yeah? Okay. Oh, be careful. I give you warning. Yeah? That those rule of thumb is only for 2 by 2 or 3 by 3. Okay, very nice, but the method will give falsely solved if you apply to a saddle point. Yeah? If the game have saddle point and then suddenly you calculate the arc, it will have a wrong result. Okay. Therefore, remember the first thing you need to do is to find the saddle point. Okay. After that, you check using domination. Okay. After that, either you use algebra or use that rule of thumb of the odd. Okay. The technique is these are the steps. Now, you can try to find. Oh, is there any saddle point in here? Or domination? Rock, scissors, paper. Is there any saddle point? And this is very interesting game actually. Yeah, there is no saddle point, there is no domination. Okay, so of course, if you want, you can calculate the R. Okay, so the problem has no finite optimal solution. Okay? So this is example that not all games have optimal solution. Okay? Oh, in the can you calculate the art in here? 2 by 2, easy. Practice. Hmm, 5 and 4. And then the other one. Wow. Right. So I give you a lot of practices here. You can do on your own. Okay. And if you do all of this, you will see I have different games. Can you see? These three games are actually different value, right? This is 16, 2, 8, 12, 8, 1, 4, 6, okay, and then 11, 4. But all of this game, if you calculate the art, they are exactly the same. With this 2, 7, and then 5, 4. Is this happened by accident? Or actually there's some pattern on it? If there's a pattern, what is the pattern? These three games, okay, you can calculate the art, right? Their art are the same, exactly the same. Do you think there's a pattern? Can you see that this value is actually 2 times of that? Yeah. Can you see that? Okay. This is 8 times 2, right? 1 times 2, right? This is 6 times 2, and then this is also times 2, right? So you can see that multiplying one game to a positive constant does not really change the art. Okay? And then, how about this? For example, you compare this and this one. Oh, you plus 3, okay? Yeah, all plus 3. So you plus with certain constant value also does not change the art. Wow, now you get a pattern, right? So why this is happening? Because this is utility. Okay? Utility, as long as you multiply or you add with certain constant, yeah, you multiply with certain constant, positive constant, of course. Okay? So in that case, it doesn't change the game. The game value changes, of course. The game value changes, but the art doesn't change. Okay? So that is what I'm telling about what is the scaling behavior. Okay? Yeah. The art are all equal. Okay? Is not by accident. Yeah? Okay? So the play of the game is not affected by adding constant, okay, or by multiplying the payoff by a positive constant. Okay, you are very good in zero-sum game. Wait, what time is it? We have time until 12. Okay, good. So let's play a real game now. Okay. So this is finished, huh? So I'm just computing this, huh? So adding constant multiplying will not change that. So this is just okay. So you can, if you want, you can practice this. Okay, so that you can do all the things. Oh, before we play the real game, let's talk about how to do it in Excel. Okay, say you can also use, if your game matrix, for example, more than 3, okay, then you start to point, or not, say 2 by 3. There is no rule of thumb, right? So yes, you can use algebra. Yes, you can do, but that's very cumbersome, right? Long time. So let's use Excel. This is the technique. Okay. So of course you can set any value to the probability. Okay, and then the sum of row probability must be 1. The sum of column probability must be 1. Right? That's clear. Okay, that is one of the a few constraints. And then you need to compute the value of the game. Okay? So compute the value of each row and compute the value of each column. How to compute the value? Easy, right? The payoff times probability, right? Okay, and then you sum. Okay, and then you use solver. Okay, this is how you set the solver. The objective is to do minimax. Yeah? Minimax of payoff times probability minus, okay, the maximum of payoff times probability, okay, so that it will become 0. Okay? So the objective is to get this equation to become 0 by changing the probability subject to constraint. Those probability must be between 0 and 1, and the product of probability and the payoff, and then you sum all of that become 1. Okay, so be careful because you are using solver. Remember I explained last time, solver is basically using Newton method, right? So initial probability matters. Okay? Initial, so you can check various value of initial values so that you can get the most often value. Okay, let's practice. Okay. Do it in Excel. So you just type this exactly the same. Okay. And what you will do, okay, this yellow you can change later. So first you will get minimax, right? So you get the minimax, you get the minimum. Okay, and then you get the maximum. Okay. For the row you want to do, so you get the maximin. From the column you can get the minimax, right? And you're supposed to get the maximin equal to the minimax, and then you can fill the probability value with any value. Okay, and then of course this one must be 1 minus this probability. The same thing here, 1 minus this probability. Okay, and then you calculate the value of the game. Let me. The changing value is the probability. Yeah. So changing the probability value. Okay, these are the constraints. Okay, so let me show. Can you see my Excel? Right. So in here I get the minimum between these two, right? Of course, this is also the maximum between these two, right? And then the probability, I can just fill anything. And this value is just, you know, some product, yeah, between the cell with the probability, this cell with that probability. So this is just some product. The same thing with the second row here. It's just this cell multiplied by this probability, and this cell multiplied by that probability. Yeah? So initially you can set anything. So I can set 0, for example. Okay. And I can set 0. Right? So after you get the game value, the objective, okay? The objective is to get the absolute value, right? So in this case, I want to make this value equal, right? The game value must be equal, right? So in that case, I just use absolute value of this 2 plus absolute value of this 2, okay? So then you just use solver. Huh? So can you see? So I just make the set objective to the value of 0 by changing the probability. I don't put any constraint here because the constraint is already there. Right? So when you solve it, oh, I did not find possible solution. Oh, did not find feasible solution, but this is already get approximation, correct? Right? So 0.1 negative 108. This is also 108. Very close. Okay, not exact, but because this is numerical value, so very close. Already. So you get the probability. Using linear algebra, using solver. Try. The value is the sum product of the cell, okay, the cell and the probability. Okay, if in the column, right, can you see this? The value is the cell, okay, D5, and this probability, okay, of D11, right? And then E5 here with E11. The same thing down here. This is the same probability, but I get the value multiplied by this payoff. Payoff multiplied by probability is the value. The same thing here. Yeah? In here you get the payoff multiplied by the probability of the row. Okay. And because our goal, yeah, the objective, right? Our goal is to make sure that these two values is the same. So then you get, example, this one, I use absolute value so that they are all the same. Try first. Is it done? Not yet. So here is just 1 minus that probability. Right? Oh, sure, please. I will close my screen. Okay, and zero. No, two cells. Only I5 and C9, right? Provided no constraint. Uh, wait. Can I see your I6 and D9? Oh no, that one is 1 minus. Yes. And then, no, no, the value is the same. Yeah, that one is 1 minus the previous. Yes. Otherwise, you need to set the constraint. But in this case, the constraint is already there. Okay, so run. Okay, you got the solution. Oh, super. Very good. Right? And you see the value of the games, they are all the same, right? Hmm. Vivi, can you make it? You want to share your screen?
Yeah, wait. I want to ask. Okay, here.
Okay.
What's to be written in the probability?
Probability you can put any number, so 0, for example. You put 0,
0.
and then the next one is 1 minus that probability. No need percentage. Equal 1 minus.
Oh. Equal 1 minus.
Yes. And then in the probability in the row, the same thing. One of them you can put any number, for example 0. And then that one you can 1 minus. Okay. Now you can calculate the value, right? So 1 by 1, you can get that equal to yeah, you can multiply by that probability I3. No. I3. Not C9.
Oh, I3. Oh, yeah. This one.
Correct. Plus
this one.
Multiply by I4. Correct. Okay. And then the next one also.
This
Multiply by that probability on the right side plus that one multiply by that probability on the right side. Okay, and then again the value in the right side in J, column J, you equal to multiply by that probability down there in C9 plus 10. Why like that. No.
Wait. This one, it should be like this one.
D, yeah. Should be D.
Nah.
3 multiplied by the probability. Yes, correct. Okay, and then the same. Equal that one multiplied by probability plus the payoff multiplied by probability. Okay, very good. So now you get the objective, which is D minus C, and then what is that? Is that correct? J minus J. Okay. Okay, good. Finish. So you just do the solver. There, the solver set the objective value. The objective is 8. Is that 8?
J.
Okay, J10. Value of 2 value of 0.
Value of 0.
Correct. Changing cell is the probability value that you put. So C9, comma I3 or colon I3. Okay. I3, I think. Not D.
Oh, this one.
Yes. No. Comma, yeah. So you only have 2 probability that you set as number, right? Those are the one that you need to find. The one that without formula. So in your case, C9 and I3. So I3, comma.
Oh.
Yes. So now you solve. There is no constraint because the constraint is already set in the equation. Oh, you found the solution. Click OK. Wow, you get it. See, look at the values, all the same, right?
Yeah.
Yeah. So, yay. Right? Look at the values, all the same. So negative 1.08. Okay. Excellent. Oh, now I want to tell you, how about if you have 3 by 3? So if you have 3 by 3, okay, the same thing like this, huh? This is, I will show you. So example, this is just example. Oh, I have in here 3 by 4 I have. Okay, so I have 3 by 4. So what you will do is, these are the things that you don't know, so you set the probability values. Okay, the same thing here, right? The last row is always 1 minus the sum. Can you see it? Okay, the last column also, you set 1 minus the sum of the all this probability that you did not, you will set as the one that you want to know. Okay, and then, okay, the objective value is, what is this? The objective value, I43. Now, here, what I'm doing is I calculate, okay, I calculate the payoff matrix with the probability. Can you see? In this matrix, I calculate the payoff matrix with the probability one by one, right? So that I will get the objective value. Huh? So again, I want to get the objective value is this one. Okay, the minimax must be equal to the maximum. Can you get it or not? But this is based on the probability multiplied by the payoff matrix. Okay, that is the one that we set here as the objective. Can you see? So here I get the minimax of this, and then here again I multiply by that probability, so I get the minimum, I get the maximum here, right? And then once you get the objective, then you do solver as the usual. Okay, but now you have a constraint. Okay, again you set the value of 0, changing cell is the probabilities. Okay, now you have the constraint for each probability must be between 0 and 1. Okay, the value of the probabilities must be between 0 and 1. Okay, that's all. So after that you just solve. Okay, is it clear or not? Should I give you this as a assignment so that you will practice? So create any size of the matrix, say 3 by 4 example, and you can put any value. Yeah. Okay. After that you do all the same, but now in 2 by 2 you conveniently said, oh, 1 minus probability, right? But once you have the size is larger than that, so now you need to set up the constraint. Okay, so what you will do is you multiply first, okay, that payoff with the probability on each row and each column. Okay, and then you get the minimax equal to maximum of those. Okay, I will give you this as your practice at home. So that means assignment. Okay. So you have 2 assignments you did not finish. Okay. Okay. So where we are. So solution to the zero-sum game. Okay, so there is a terminology of called poor play. Sometimes you read in the news also, right? Oh, that is poor play. What does that mean? If your opponent does not play rationally, okay? Poor play means they play irrational. Okay? So, for example, if a saddle point exists, you know that you always guaranteed to get better than the value of the game even in one game. Yeah? If you have a mixed strategy in the long run, yeah, if the game is played, the same game is played repeatedly, you always select the optimum strategy. Then your average winning is always better than the value of the game, right? So if you do a poor play. Okay. But if you do rationally, then all this theory that we discussed in the class will be correct. Okay. So why sometimes it doesn't happen in reality? Yeah, because they are not doing it rationally. So, and one thing I want to tell you, sometimes playing irrationally will make you win. Okay, so if they know that you will play rationally, so sometimes if you play irrationally, sometimes can make you win. Okay, so this is the summary. Okay, zero-sum games is strictly competitive games, right? Equilibrium happen when the maximin is equal to minimax. Okay? And if you inform your strategy to your opponent before you play, actually you will not gain any advantage or disadvantage. Information does not play a role here. Okay? So, and joint plan of action and communication prior to the game has no benefit. Okay, so this is the summary of zero-sum games. So I put here in computation, okay, in zero-sum game, of course, first thing, if you look at the game, you look at it first. Is this zero-sum game or not, right? If it's zero-sum game, then first you need to find saddle point. If does not exist, you use domination. If does not exist, then you use mixed strategy. Yeah? Use mixed strategy, either you use art or you use linear programming. Okay? So, that's all for this topic. Is there any question? Clear, or is this too fast or okay now? So I'll give you okay. I'll give you an example of the application of game theory so that at least it will motivate you. So the slide is threat and credibility. Okay. I know I did not talk about non-zero-sum game yet, but let's discuss about this first so that you will see the usefulness of game theory. Yeah? Anyway, we have only 15 minutes, so I think we can start with this one. So, this is application of information in the game theory for non-credible threat or credible threat. Sometimes in the organization, in the company, okay, you want to make the people work for you correctly, right? Yeah. So sometimes you want to control. So then you create a threat, right? So now we are talking about credible threat or non-credible threat. Yeah, in Indonesian, ancaman. Right? Okay. So information play important role on threat credibility. Last time we discussed about most grade school teacher actually has her self-interest for not informing the parent about children misbehave, right? Why? Because it will upset the parent, and teacher realized that children bad behavior was mostly teacher's fault, okay? Because probably had not been acting like a real teacher. But the children does not know this, right? So the teacher threatened the children to behave well, or else, okay, the teacher will report to the parent. So now, if the children knew the teacher's self-interest, then they will decide not to behave. Actually. So this is the point of information. Yeah? So you know the child can behave or not behave, okay? And me as the teacher can tell the parent or not to tell the parent, right? So now another example. The parent threatened to disown the daughter if she gets pregnant. So my question, should the daughter believe that threat or not? Example, okay, your parent tell you, if you get pregnant, I will not treat you as my child. Okay, so you as a daughter believe that threat or not? Okay, the answer is no. If you know that your parent actually love you, right? And yes, you will believe that threat. Okay, she will believe that the threat was made to improve her welfare. So you know that actually this threat is for you, okay, for your own welfare. So if it happened that she got pregnant, okay, it will not be in the interest of caring parent to actually carry out the threat, right? So this is called non-credible threat. So now, in Indonesia especially, you can see a lot of demonstration in a lot of companies, right? So demand for raise, okay, minimum wage increase and so on, right? So the question is, why should your boss give you a raise? Why is it in her interest to be nice to you? Right? So you have any chance at getting a raise if your company will be worse off without your labor. What does it mean? It means you have certain unique value for the company, right? So you are very valuable for the company. Then if you ask for the raise in your salary, yes, you probably will get the raise. Okay, so your best chance obtaining a raise, therefore, okay, lies in convincing your boss that you will leave if you don't get the money. Okay, so you threat your boss now. Okay. So the question is, why should your boss believe on your threat? Huh? So here is the game 3. Huh? So you will ask for the raise, right? So the boss have two choices, okay, to give raise or not to give raise. Okay. So if the boss give raise, surely the boss will keep you, but say need to pay you 20,000 more. Okay. If the boss not give raise, you have two choices, right? To quit or not to quit. Okay? If you quit, the boss will lose you. Okay. If you don't quit, the boss will keep you at the old salary. So now you can start to create the payoff matrix for this game, right? Can you see the situation? Okay. So here, this is a payoff matrix of that situation. Say your boss, okay, value your work actually at, say, example 150. Okay, and you demand to raise 20 from currently 80. Okay, so let's put that. So the actual work is actually 150, okay, minus 150. If you quit, yeah, if the boss gives raise and you still quit, okay, so this is the payoff for the boss, right? So minus 150, this is your actual value, okay, and then plus 80, okay, your current salary, minus 20 of your raise, right? And if the boss not to give raise and you quit, okay, your value is actually 150 negative because it's from the boss point of view, and then 80, okay, your current salary, right? So the total is minus 70. Now, if the boss give raise and you decided not to quit, okay, this is positive 50 total for the boss. And if the boss decided not to give raise and you don't quit, positive 70. So these are the game matrix that you can start to create. Huh? based on that situation. Okay? And then what you will do, the same as before. So the problem here is information. You understand? You don't know this 150, isn't it? Right? The problem is you don't know how much the boss value you. Okay? If that 150 is if you know, then you can create that game matrix. So if you don't know, you guess. Right? So if you don't know, you guess, because you don't know, this is your game matrix. So totally different from your boss game matrix. Okay? This is the value of information. Can you see that or not? Okay? So because of that, if you look at this, both of two matrices, your payoff matrix and your boss payoff matrix is actually both are zero-sum games. Okay? The difference is because of the information. Right? So then you can find the saddle point. Okay? And you also know you have different information from your boss. So you can also calculate that. Okay? And I calculate this using Excel. Right? You see? And this is the result of the games. And you may think the best is not to demand any raise. Okay? And based on this game, the boss may think that if you may quit, if he did not raise your salary. So different in perception between people because they actually create different payoff matrix. Okay? Then from there, you can actually create another payoff matrix with this non-zero-sum game. Can you see that? Assuming that you know the information about your boss valuation and your boss also know about your payoff matrix. So we can combine those two matrices above into one. So now become non-zero-sum game. Can you see the bridge between zero-sum game and non-zero-sum game? Okay. Earlier you have always discussing about zero-sum game, right? Now I'm telling, look at this example. I have two different people. They have different perception of the same situation. Okay, because of the information. Then you can create non-zero-sum game based on those two. Is it clear or not? Okay. From here, then of course you can simply calculate. Okay. So if you calculate, the result is this one. Yeah? This is domination. Okay. So the result is without credible threat, both you and your boss may think the best way is not to demand and raise and not to quit. Okay. So then the question is this. How to make a credible threat? Oh, this is the application, right? So something that, okay, to make a credible threat, okay, you pretend that you are crazy. Okay? You are irrational. Okay? So, for example, one way is to tell that, oh, there is another company offer you higher. Right? So, the best way to make a credible threat is to prove to your boss, oh, you see, there's another company will pay higher salary. Then the threat become credible. Yeah. Okay. In the history, you see to make the threat credible. In This is called Cortes during the war. Okay, so Cortes want to win the war, and they know the soldier is have very low morale. So when they enter the land, okay, he burned his own ship. Okay. Why? By burning their own ship, they have eliminated the choices, so that will increase the payoff. So this is a crazy. They burn their own ship so that the soldier have no choice but to win. Otherwise you die. Okay. So the same thing. Okay. Another way to get raised will be to tell everyone in the form you are crazy, right? So that you definitely will quit if you don't obtain it. Right? Because you are so ashamed that you don't get it. So then you put yourself in a position where you will suffer complete humiliation if you are denied the money and you still stay in the job. So your goal should be to make it is so painful for yourself, okay, to stay, right? Then you know that threat is credible. The boss know that this threat is credible. So this is the application of game theory. So is this interesting or not? Okay. Okay. So this is, if you practice, so the same technique here. So now you put here to make the threat credible. Okay. We put negative 1,000 here, for example. Yeah. So it's so painful to yourself. Okay. Right. So you put minus 1,000 here. Then the subtle point you can compare, and you will see, yes, of course, the threat become credible. Okay. And if you find the equilibrium, you will see the equilibrium change, right? Okay, so you will quit if your boss will not give raise. Okay, this is your payoff, right? So you don't know the boss payoff, actual information. So this is the actual result. So as a conclusion from this lesson, okay, so securing a reputation of honesty is also increase your credibility. Okay, honest behavior arises from actually self-interest and morality. You know, to make yourself, you are famous to become honest, with integrity. That means actually that is self-interest. That is not just moral. Okay, that is the lesson of game theory. So don't think that about morality, just morality. There is self-interest inside the morality that make it work. Okay, the same thing here. Okay, a kidnapper demand ransom, right? But the victim family should comply only if the paying ransom actually increase the chance that the victim getting released, right? Okay, so in the Philippines there is Abu Sayyaf in the southern Mindanao that always kidnap everyone, right? So including the Indonesian, they even kidnap the Muslims. So they are telling they are Muslim, but they also kidnap the Muslim anyway. Basically, they are terrorists or criminal. Okay. So the victim family will pay ransom only if they believe it will increase the chance, okay, that you're freeing the victim. Okay. A kidnapper planning on plying his trade, so like Abu Sayyaf is, okay, they know this is their business. Okay? They want to get the future kidnapping business. So they also have a reputation for honesty. So remember, kidnapper is not always bad. Yeah, they cannot be honest also. If you pay them, they will always release. Okay? So a repeat kidnapper, this is kind of strange, but this is true. This is happening. Okay? So a repeat kidnapper wants his victim family to know that in the past he has released the victim. Only if the demand is met. Right? So that means even kidnapper need to have an honesty. Funny, but this is true. Because of the game theory, you start to realize the behavior of the people. Honesty is not always because of the morality. Okay? It's a self-interest. Okay. So business the same thing. Okay. So if the business have greater incentive to treat their customer fairly, okay, then they plan to play the game again, right? So in that case, the question is, why should Acme, say the name of the company is Acme, why should Acme company treat the customer fairly, right? And should the customer go to Acme, right? So if the customer go to buying Acme product, right? So this is the choice, right? The customer have two choices, to go or not to go. Okay. So if not to go, will get 0. If go to the Acme, have two possibility for the company, to exploit or to treat fairly. Okay. And this is the payoff matrix that you can fill in. Okay. So at the end, you will see that actually for the long-term play, okay, if the business treat fairly, even gets so small, actually it's better. Okay? But at the end, if you want to play repeated game, at the end, the business can also exploit the business. This is happening in usually gambling business. The scam, right? The scam. Usually, the one that just recently got a problem with the OJK, right? Right? First time they play nicely, so they pay all the customer, and then suddenly they reap all the reward and then go away. Okay, so that is how the business also can do fairly in the beginning, and then at the end they get everything. Okay? So again, based on the self-interest, you start to realize game theory can be useful, yeah, to analyze this situation. Okay, thank you very much. So see you again 1 p.m. after lunch. Okay, so let's come back a little bit to the thread a while ago. Okay, can you see my screen? Right. So if you create a business, right? So this is one of the application of this game theory thing. The true catalyst of business honesty is actually repeated play, right? So in the long run, say this Acme company will be better off if they play honesty, okay, using this game that we put in here. And you can see that completely selfish and greedy company Acme, okay, would profit by treating the customer fairly and honestly. So this is to prove the point that, look, honesty is not necessarily moral. It's practically self-interest. The same thing with why company need to invest in brand name, right? It's like burning money, right? So basically that is to prove their trustworthiness. So this based on the threat and credibility. So they want to appear, at least appear credible. That's why they invest a lot of marketing in making branding. Okay. So many people in business exhibit honesty not because they are moral, but because they are greedy. In fact, people think in Asia especially, people will think, oh, you are greedy, you are immoral or something. It's reverse. Yeah? If mathematically we can check, okay? Mathematically we can check that moral has nothing to do with greed, okay? And honesty can be greed, right? Not necessarily because of moral. So the key actually is repeated play. Okay? So a firm that was about to face bankruptcy, okay, suddenly they may cheat you today, even though it has a long honesty in the previous dealing, right? So it's not just about moral, but about the self-interest, basically. So now consider this game. So you and the competitor, if the competitor being nice, both will get 1,000. Okay. If the competitor being mean to you, okay, then you have choice: being nice to the competitor or being mean to the competitor also. So if you also being nice, the competitor will get 2,000, you get 100, right? And if you being mean, I mean tit for tat, right? Meaning you take revenge, both will get 0. How often this situation happens? So should you take revenge or not? Right? So this is a normal situation that you often also face in real life. Okay, so now since the competitor move first, rationally you will play nice to get 1,000. Okay? So depending on who moves first. Now, if the game is played simultaneously, okay, you will still play nice. So you can check the payoff here, right? So the question is how to force the competitor to play nice so that you will get 1,000. That is the point there, yeah? So the way to make the competitor play nice, okay, is this. So if the competitor thought that you were interested in seeking revenge, okay, to win irrationally by being mean, okay, but not rationally to maximize your payoff, he will be nice and you will get 1,000. So this is a paradox, okay? A person who rationally cares only about money actually will make less than someone who has irrational and make the first goal. So this is simple games that you can actually play, okay? And the numbers you can play out. Remember, this is utility, so you can just put any number as long as the order matters, okay? So if you want the competitor to be nice to you, and if you make the first move, then you need to be nice to them. But if they make the first move, you probably need to be nice. Or okay, you start to think. If you play simultaneously, then you start to think about maybe you should create a perception. Okay, you need to create a perception that you are going to seek a revenge. Then they will change their behavior. So again, perception, information matters. Okay? This is how you can start to play. Okay, so something that probably not taught in other way. Right. So they will start to play irrational. So this is I'm telling this. The title is Benefit of Insanity. So being perceived as irrational can be advantageous. Okay. So your competitor will make her decision not based upon whether you're actually interested in revenge, but whether she thought you are interested in revenge. Okay, so revenge is irrational behavior to harm others who have injured our loved one. Okay, but the optimal strategy is to adopt with respect to legal vengeance, rather to convince people that you are actually insanely okay attached to vengeance, even though you are not. Can you see that? Okay, so if someone did violate your legal right, then you will really rationally evaluate whether to sue or not, right? But creating a perception sometimes is useful. Wow, I'm talking strategy and tactic here. So, correct? So, in summary, okay, fear only credible threat, right? So you trust only credible promise, of course, right? So player who wish to have repeated play need to increase their credibility, including that kidnapper. Okay, so this is how you improve credibility. Number one is to show that you have other alternatives. Okay? Number two is to show that you have no choice but to fight, right? Another one is to create an honesty reputation. Perception is important, so brand name, for example. Or you create a suicide, so telling your move publicly. Okay? Or the last one is to be perceived that you behave irrationally. Any comment? So, what did you learn? Did I did I teach you to be wicked or? Again, this is science, okay? So I'm not attach any moral issue here. Okay, so this is practically mathematics that you can also calculate on your own. Okay? You don't need to believe me, you calculate on your own. I show you how to compute already. Right? So it's important in science to be objective rather than, based on our attachment to certain things. Okay, so I want to play games with you. If you have no comment, I want to make games with you. So since this class only have two, that's okay. So this is at least 2 students, okay? Otherwise, I will not play this game. So, okay. This is the game I created for this lesson. So, share. Okay. So actually, this is called Prisoner Dilemma games, or basically system thinking games, okay? So, the purpose of this game is to reveal your way of thinking. Okay? Paper, notepad, that's fine. I did not bring a paper pen anyway. I will just put in the Excel. Okay? To reveal your way of thinking through cooperation, competition, trust, and negotiation. Oh, nice. Okay? It's a very simple game. So, you can choose to cooperate among the two of you. Okay? Or to betray. Okay, so you can choose. The choice is only two: to cooperate or to betray. But again, before playing this game, I'm telling you, do not feel bad if your team is betrayed by if you be betrayed by your friend. Okay, this is just game. So, in fact, to make it more fun, actually. But it's up to you. This is just game. Don't take it personally, okay? Okay? Okay, so the class is divided into two, or individual, okay? So you can, so anyway. So we have 8 rounds. We will have 8 rounds. I will write down in the, can you see my whiteboard?
You need to turn off your virtual background first.
Okay, I need to
Yeah.
virtual background. So how to do that. I cannot.
There should be an option in the video settings.
Yeah, but I cannot enter video setting because if I join, okay, let me check. One. Eh? Oh, it will convert my